All right, welcome to our unit on solutions. When we talk about solutions, we're going to be talking about a lot of different mixtures of compounds, and so let's just get right into it. Today we're going to learn a little bit about what a solution is, so we should be able to define and explain a solution. We're going to talk about these three words right here, what unsaturated means, saturated, and supersaturated. And then we're also going to talk about the concentration of a solution, how concentrated it is. Is it really concentrated, not very concentrated, etc. So the solution process, just like when we finished up our gas unit, when we were talking about gases, one of the things we said about when a gas mixes with another gas is that it forms a homogeneous mixture. And we've learned that homogeneous means it's a uniform mixture throughout. When a solution is formed, the same thing happens. A homogeneous mixture is formed. And again, there's no chemical reaction that happens. It's simply one thing disperses or dissolves in another. So we can actually think of two gases like oxygen and nitrogen. When they mix together, they actually form a solution. So in that case, obviously one gas is not dissolving in another, but the gases are dispersing evenly throughout the container that they are in. And so that can be considered a homogeneous mixture. So all solutions are homogeneous mixtures in that they mix evenly with each other. Okay, so a lot of times when we think about when you put salt in water, you see that salt disappear. And you think, well, that's a chemical reaction. Okay, there is no chemical reaction taking place when you dissolve salt in water. The salt is just getting into smaller pieces of salt that you can't see. So there is no chemical reaction that takes place when something dissolves or when two things mix together evenly. Okay, in every part of a solution, there are three different parts to it. Number one, there is what's called the solute. And the solute is the substance that is being dissolved in the solution. So clearly, when we're talking about this type of solution, we're talking about something being put into something else, and there's going to be something dissolved. So the stuff that gets dissolved is called the solute. So in that example that I just gave you, the salt would be considered the solute. And so when you have a solute, you're also going to have what's called a solvent. And a solvent is the thing that makes the solute get dissolved. And like it says here, the solvent is typically water. Water will dissolve a lot of things. And then you put those two things together and you make the solution. So a solution is a combination of the solute and the solvent. Now, like I talked about earlier with two different gases or salts dissolving in water, there's actually 6 different ways that solutions can form. Okay, one of them is, like we just said, a gas with another gas, such as air. Air is a homogeneous mixture. Okay, you can take a gas and you can dissolve it into a liquid, such as a can of pop. Okay, a can of pop has water in it and it has carbon dioxide gas dissolved in it. Okay, so that's an example of a solution. A gas can also be in a solid, such as if you take a piece of metal and you put some gas into it, such as hydrogen in palladium. You can have two liquids together, such as ethanol and water. They will mix together evenly. You can have a solid and a liquid, such as salt and water. And then you can have two solids mixed together. A lot of times people think that if you take like a piece of gold and a piece of platinum and you melt them, there's a chemical reaction that happens. That is not true. When you put two solids together, you melt them and then let them harden, no chemical reaction has happened. They have simply mixed together evenly. Now, when we talk about concentrations in a solution, we need to talk about the saturation point, or a saturated solution. A saturated solution, and you've probably heard that word before, oh, it's saturated completely, means that the maximum amount of solute is dissolved in that solvent. So for example, if you have a glass of water and you start putting salt into it and you stir it up, the salt's going to disappear. And then if you add some more salt and you stir it up, it's going to disappear. But you're going to get to a point where no more salt will disappear. That basically there's not enough room for that salt to dissolve. And so when you've reached that point, you've reached what's called the saturation point, and you've created a saturated solution. And so a saturated solution is a solution where you can't dissolve any more of that substance in the solution. If it's unsaturated, well, that makes sense. It means you can still dissolve more. And if it's supersaturated, it's a solution that contains a greater amount than a saturated solution. And typically that occurs when you heat up water. So, for example, a lot of times when you hear about like rock candy, things like that, that is formed, or even syrup. Syrup is a good example of a supersaturated solution. When you heat up the water, more of the sugar will be able to dissolve in that water. And so you can create what's called a supersaturated solution. Now, let's get a little bit more into concentration. Okay, a lot of times when you think about, you make Kool-Aid or something like that, when you make Kool-Aid and you don't put enough sugar in it, you might drink it and go, oh, it's not concentrated enough. Or you might say the words, it's not strong enough. Or you might put too much sugar in or too much flavor in it, and oh, it's too strong. When you're using those words, it's not strong enough, or it's not concentrated enough, or it's too strong. Basically, what you're doing is you're talking about the concentration. You're qualitatively, remember qualitative means without numbers, you're qualitatively describing the concentration. Okay, what we're going to do is we're going to quantitatively, or with numbers, describe the concentration of a solution. So quantitatively, remember, deals with numbers. So the concentration is the quantity, so amount, of solute present in a given quantity of solvent or the entire solution. So basically what we're going to be measuring how much solute, whether again salt, sugar, whatever, it doesn't matter, is present in a given amount of a solution. And there's going to be 4 different ways that we're going to measure that. And some of them you're actually already familiar with. One of them is mole fraction. We just learned about in our gas unit. Remember that mole fraction, we use the letter X for that. And it's going to be the moles of whatever, A, over the total number of moles. And remember that is a decimal. Even though we call it a mole fraction, we write it as a decimal. There is no units in mole fraction. Okay, another way we're going to learn about this is called the mass percentage, or the percent by mass. That is the same thing. And we're going to talk about this thing called molarity. That's probably the biggest one. I would put an asterisk by that. That's the one we're going to end up using the most. And then the 4th one is called the molality. Notice just a very slight difference there between those two, molarity and molality. Those are 2 different things. Okay, so let's start with number 2. I'm not going to go over mole fraction again. I already did very briefly. We already learned about it with gases. So the percent by mass, or the mass percentage, is the mass of, again, the solute. So again, that's not the water. That's going to be your salt, your sugar, things like that. And you're going to divide that by the total mass of the solution. Now be careful there. The total mass of the solution is not just the water. It's going to be the water plus the original salt. When it says the solution, remember the solution is the solute and the solvent together. So when you do these problems, it has to be the mass of the entire solution on the bottom. And then obviously to get a percent, you're going to multiply by 100. Okay, so here's an example of this. It says a solution is made by dissolving 13.5 grams of glucose in 100 grams of water. What is the mass percentage of glucose in this solution? So to solve this, we want to take our 13.5 grams. Oops, back that up there. We want to take our 13.5 grams of glucose. So we're going to go 13.5 13.5 grams over the mass of the entire solution. Now notice the way you have to pay attention to how I write this. If I say 100 grams of water, that is the solvent. That is not the entire solution. So I'm going to put 100 grams, that's the water, plus my 13.5 grams of the glucose, the sugar. And now I'm going to multiply that by 100. And that's going to give me my answer. Now, if I come back here real quickly, if I had said 13.5 grams of glucose in 100 grams of solution here, then that would mean that I'm including the sugar as part of that. So you really have to pay attention to what that mass is to determine, do I need to add the solute or do I not need to add the solute? Because if I say the word solution here, that's saying that I'm including the sugar or whatever it happens to be in the mass, in this final mass right here. In this problem I did not, I just said water, so therefore we have to figure this out based on the water and the sugar combined. So to solve this problem, I'm going to get out my calculator and I'm going to go 13.5 divided by, and then in parentheses, I'm going to go 100 plus 13.5. So on my calculator, 13.5 divided by parentheses 100 plus 13.5, close parentheses, and then I'm going to get my answer. So I'm going to hit equals, and then I'm going to times it by 100 times 100 equals, and now I'm looking at my significant figures, 100, 3, 3, so I'm going to go call that 11.9% as my final answer. Okay, let's look at another example. Okay, in this one I say 6.44 grams of magnesium chloride is dissolved. And notice I give you the formula here. That's not really just to mess with you, it's just to kind of make you think a little bit about, okay, what's the formula of magnesium chloride again? Okay, magnesium's plus 2, chlorine's minus 1. Okay, it's MgCl2. 6.44 grams of magnesium chloride is dissolved in 80 grams of solution. So again, notice on this one that I changed it and I said solution. So to solve this one we just take 6.44 grams and we're going to divide it only by the 80.1 grams of the solution. And remember, whenever I say solution, it means that I'm including the 6.44 as part of my problem. So 6.44 divided by 80.1 multiplied by 100 again equals 8.04%. Check your math. Make sure you're doing the math along with me. Make sure that you're getting the same answer I am. Number one, to check and make sure I'm doing it right. Number two, make sure you know how to put it in the calculator correctly. Okay, and then again, I'm telling you here, you do not need to add the mass of the solute because it says solution. I already told you that. Okay. Okay, our third way to measure concentration. So we talked about mole fraction. We talked about percent by mass. Our third way to measure the molarity or the concentration is by the molarity. The molarity is abbreviated with a capital M. And the way that you find the molarity of a solution is it's the concentration of a solution defined as the moles of the solute per liters or volume of the solution. So the moles of the solute go on top, the liters of the solution go on the bottom. And like I told you, this is the big one. This is the one that we're going to end up using in AP chemistry or college level chemistry when we're learning about acids and bases and we're learning about all other different types of chemistry. This is the one that we use the most. Okay, so moles of the solute. If I give you grams of the solute, what do you have to do? You have to convert it to moles. Okay, that's on the top, and on the bottom is the volume measured in liters of the solution. And yes, it must be in liters. If it's in milliliters, you have to convert it to liters. Okay, a shorter way of writing this, remember using the gas letters. Capital M molarity equals N, which we know stands for moles, over V, which is obviously the volume. Okay, so here's an example of this. What is the molarity of a solution that contains 2.56 moles of HCl in 2.5 liters of solution? So when we look at that, we're going to put our moles on the top. 2.56 moles over 2.50 liters of solution. And we're just going to divide those two numbers. There's no multiplying by 100. There's none of that. So 2.56 divided by 2.5 equals 1.02. Now there's a couple of different ways you can write your answer here. You can write just 1.02 big M, like I showed you before, or you can actually write it as 1.02 moles per liter. Either of those two different ways is a perfectly valid way of writing your units for molarity. Okay, here's another example. How many moles of a substance are dissolved in 3.25 liters of a solution with a molarity of 0.258? So again, here's our equation up top. And in this case, they're not asking us for the molarity. They give us the molarity. So they're giving us this, and they're giving us this. Obviously, what are we looking for? We're looking for the moles of the solute. And so, again, think about how we do the math here. How do we do the algebra? We need to get moles of solute by itself. We need to get that one all by itself. So to get liters of solution out of there, we need to multiply both sides by liters of solution. So we can say that the moles of the solute are equal to the molarity times the liters of the solution. That's your algebra right there. That's multiplying both sides by liters of solution and canceling it here on this side. So to get moles, we're going to take our molarity, 0.258, big M, which again stands for moles per liter, times the volume of our solution, 3.25 liters. And clearly now all we need to do is we need to multiply those two numbers. So 0.258 times 3.25 equals 0.839 moles. And again, that's moles of the solute. And again, they don't tell us what it is, so it doesn't matter. But that is our final answer there. All right, now that we're going to go ahead and stop there for now. So that is an introduction to percent by mass, mole fraction, and the molarity of a solution. There is another PowerPoint where that fourth one, the molality, we're also going to talk about. But for now, that is the introduction to solutions.